Okay, so here's another problem I would want to talk about today for the L'Hopital's rule. It's the limit for x goes to 1, and we do have the function of x over x minus 1 minus 1 over natural log of x. So first thing that you want to do, you want to combine all these terms together. So once you combine them, we do have x natural log of x minus the quantity of x minus 1 all over x minus 1 times natural log of x. And then by checking the limits, so this one plugging the number, so we got natural log of 1, 1 minus 1 is all 0. And then denominator, 1 minus 1, so that's all 0. So 0 over 0, which is one of the indeterminate forms. And then from here, we want to take the derivative top and bottom. So derivative at the top, we got x, use the product rule, and then 1 over x plus natural log of x, and then minus 1. And then for the denominator, also we need to apply the product rule. So we got x minus 1 times 1 over x, and then plus natural log of x. So we try to simplify this a little bit, cross cancel, so that turns out to be 1. And then we got natural log of x on the top. So 1 minus 1, that just gives you 0, so we're just left with natural log of x on the top. And then denominator, so try to distribute, so what we got here, it's 1 minus 1 over x, and then plus natural log of x. And now from here, we want to plug in the number again. So x equals 1, so natural log of 1, that's 0. And then 1 over 1, subtract from 1, it's 0 again. So that's another part of the indeterminate forms. And we want to use the L'Hopital's rule one more time. So derivative top and bottom, so we got 1 over x. And then divided by 1 over x squared plus 1 over x. So now from here we can just plug in the number. So again, x equals 1. So we got 1 over 1, which give you 1. And then 1 over 1 squared, that's 1 again. And then plus 1. So finally, the limit is going to be 1/2. So now let's try another problem. So this time we're using black for the background. And the one that I want to show to the class, so that would be considered, okay, so here's the one. It's the limit. So x goes to infinity, and then x to the power of 1 over x. So anytime they see that the variable to the power, so what you need to do, you want to set y equals x to the power of 1 over x. And back to what you learned from Algebra 2 and Pre-Calc, so we can always bring down the power by taking the natural log. Natural log or ln. So we got 1 over x, natural log of x. And also this one can be written as natural log of x over x on the right hand side. So now x goes to infinity, so natural log of infinity, which is considered infinity. And then x goes to infinity, so that's infinity again. So this one is just one of those indeterminate form. It's infinity over infinity. So what we can do on the right hand side, we can take the derivative top and bottom. So we got 1 over x, and then over 1. And now from here we can plug in infinity one more time. So 1 over infinity, we do have 0 over 1. So that means the limit for natural log of y equals 0. And in order to get rid of that natural log, we can just take base e both sides. So we got y equals 1. And that would be your limit when x goes to infinity.